School Tech. In this episode, we're going to look at the construction of a gravity-powered catapult called a trebuchet. I'm going to point out some tips that you may want to consider, as well as some pitfalls to be avoided if you should decide to build one of these yourself. At the end of every section, I'm going to put a summary screen that contains some more information, so you may just want to pause the video at those points if you need those details. So one of the factors that's going to influence the design of your trebuchet will be how tall do you want the final device to be. I know that we want ours to hide behind our fence because our homeowner association has complained if I've left a catapult out in front of the house. And so I knew I wanted to be less than, say, 6 feet, which means about 180 centimeters. So I decided to go ahead and use a design that has my supporting braces at a 45-degree angle to the main support. And that means I'm going to make my supporting braces about 180 centimeters. And then I'm going to make my central support about 150 centimeters. That'll mean that the central support will rise up above the supporting braces just a little bit so I can put my fulcrum in there. Okay, so the final support brace is 180 centimeters long on the long side with a 45-degree cut here and a 45-degree cut on the other end. And then this is the mainstay, and it is going to be 150 centimeters long. So when I put them together, they're going to go like this. The other 2x4 is going to go over here, and I will join all those together with a T-strap. So here is the rough framing of one side of my trebuchet. I put a T-strap on here. Also, since this is the inside, this is on the outside. If I get ambitious, I might cut a nice piece of plywood and make like a little frame right over here to kind of give it some other support, but also make it look a little bit better. Once you get the main beam and the two braces installed, you can use a T-strap to put on the base of the trebuchet. And over here, I just use the miscellaneous strap to hold the two braces on to that same base. I attach the sides of my base first, and then attach one of the cross pieces to each side using right angle brackets. This allowed me to attach the cross pieces with the sides laying down. Then I lifted the sides up and attached the brackets to the other side. Next, we drilled holes in the mainstays. It's important to get the holes at the same height on each side, so I used the same piece of 2x4 as a guide on each side and used a level to make sure the 2x4 was held vertically. I also used a mounting bracket for a 1.5-inch pipe to provide extra support for my fulcrum. Now this trebuchet will use a sling that slides out from underneath the throwing arm. Some trebuchets have an actual channel underneath the arm that the sling follows. I decided that for now it will be sufficient just to use some flat, smooth pieces of plywood. These pieces of plywood are 4 feet by 2 feet, so they do not run the entire length of the trebuchet. Wheels are handy on a trebuchet for 2 reasons. First, to make it easier to push the trebuchet around when you want to move it, but also they allow the trebuchet to rock back and forth while the weight is dropping, which allows the weight to drop more or less vertically downwards. The design of the throwing arm is critical to building an effective trebuchet. It needs to be long enough so that the end is moving fast at launch time, and strong enough not to break, but not too heavy. I chose to make the launching side of my throwing arm 3.75 times the length of the counterweight side. To increase the strength of my throwing arm, I reinforced it with 2x4s on the counterweight side. I constructed a counterweight box with a mass of about 18 kilograms, or a weight of 40 pounds. Getting the sling just right is tricky. The size of the pouch you need depends on the projectile. I used a design from the Team Urban Siege website. The ropes are attached to the pouch. I chose to use ropes that were about as long as the launching side of the throwing arm. So now I have the entire trebuchet assembled. I have the sling attached. I put in two 10-kilogram masses in addition to the weight of the counterweight box, giving me a total of about 80 pounds of counterweight. And I'm going to use it to launch a baseball. So let me get that set up. And I think we are ready to launch. 5, 4, 3, 2, 1, launch.